Welcome to this detailed masterclass on airflow measuring stations, or AFMS, an essential piece of modern HVAC design. Whether you're just starting out or already an experienced engineer, mastering airflow measurement can help you design more efficient, comfortable, and reliable systems. Let's break it down step by step, from the basics to advanced practices. You'll discover how AFMS technology improves energy efficiency, ensures proper ventilation, and supports compliance with building codes. We'll also cover common challenges, troubleshooting tips, and best practices for installation and maintenance. By the end of this guide, you'll be equipped with the knowledge to optimize airflow measurement in any building project. An airflow measuring station is a device installed in ductwork to accurately measure the amount of air passing through. It uses differential pressure tubes, blade arrays, or thermal sensors to determine air velocity and convert that to airflow in cubic feet per minute, or CFM, or liters per second, which we call LPS. These stations are essential for maintaining proper ventilation, energy efficiency, and indoor air quality in buildings. Regular calibration and maintenance ensure their accuracy and reliable performance over time. If airflow isn't measured and balanced, some areas may be overventilated while others are underventilated. This leads to discomfort, poor indoor air quality, wasted energy, and can overload fans and chillers. An AFMS ensures you deliver the design airflow and comply with standards like ASHRAE 62.1 for ventilation. It also helps facility managers monitor system performance over time, making it easier to identify issues early and schedule preventive maintenance. Ultimately, proper airflow measurement supports occupant well-being, reduces operational costs, and contributes to achieving green building certifications. Common types include, first, pitot tube arrays, where multiple tubes sample pressure at different duct points. Second, thermal dispersion sensors, which use heat loss to estimate velocity. And third, fan inlet measurement, which measures fan speed and static pressure directly at the fan housing. Additionally, differential pressure sensors are often used to calculate airflow by measuring the pressure drop across a known restriction. Ultrasonic flow meters are another option, using sound waves to determine air velocity without any intrusion into the duct. So, each airflow measurement system has its own set of pros and cons. Pitot arrays, for example, are pretty simple to use, but they really need clean, straight duct runs to work well. Thermal sensors, on the other hand, can fit into tighter spaces, but, well, they do come with a higher price tag. And, if you're using fan inlet measurement, just remember it needs factory calibration to be accurate. No matter which system you choose, proper sealing of duct joints and connections is essential to prevent air leaks and ensure accurate readings. Also, make sure all wiring is installed according to manufacturer guidelines to avoid signal interference or faulty measurements. Finally, always refer to the installation manual and follow recommended maintenance schedules to keep your airflow measurement system performing at its best. You should always install an airflow measurement system on a straight section of duct where the airflow is nice and uniform. It's important to avoid spots right after bends, dampers, or branches, since those can mess with your readings. And don't forget to follow the manufacturer's recommended clearances both upstream and downstream. Usually you're looking at about 5 to 10 duct diameters for the best accuracy. Also, make sure the duct section is well sealed and free from leaks, as air escaping can affect your measurements. The inside of the duct should be clean and free of debris, since buildup can disrupt airflow and sensor accuracy. Finally, always double-check the airflow direction and install the sensor according to the manufacturer's orientation guidelines for reliable results. An airflow measurement system connects to your building management system, or BMS, using analog or digital signals. It provides real-time airflow data, which is super helpful during commissioning, balancing, and troubleshooting. You can use this information to adjust dampers, VAV boxes, and fan speeds, making sure you're getting the most efficient operation possible. Reviewing historical airflow data can also help you identify patterns, spot inefficiencies, and plan preventative maintenance. Plus, automated alerts from the BMS can notify you of abnormal airflow conditions, so you can address issues before they become bigger problems. So, always match the AFMS type to your duct size, your expected flow range, and of course your accuracy needs. Make sure you verify if you actually have enough space for proper installation. And, consider maintenance access. Sensors really need to be reachable for cleaning and calibration. Also, double-check wiring requirements and compatibility with your building management system to avoid integration issues. If your AFMs will be exposed to outdoor conditions, select weatherproof models to ensure long-term reliability. And finally, always confirm that your selection meets local codes and certification standards for safety and performance. Advanced projects, well, they must comply with ASHRAE SMACNA, and sometimes even ISO standards. For instance, ASHRAE 62.1 governs minimum ventilation, while SMACNA details duct construction and testing. Plus, local energy codes may also require documented flow measurement and verification. Additionally, projects aiming for LEED or other green building certifications must meet even stricter documentation and verification standards. Always check with local authorities as regional codes and permitting requirements can vary and may impact your airflow measurement approach. AFMS accuracy really depends on duct conditions. Turbulence, swirl, and poor installation, these can all create pretty significant errors. Always check the rated uncertainty, it's usually around plus or minus 2 to 5%. And to verify, perform a manual duct traverse with a calibrated handheld device during commissioning. Regular maintenance like cleaning filters and ducts also helps minimize measurement errors caused by debris or blockages. Environmental factors such as temperature and humidity can affect sensor readings, so ensure sensors are properly calibrated and installed. Following manufacturer guidelines and industry best practices will further improve the reliability of your airflow measurements. After installation, always calibrate your AFMs on site. Compare readings with a trusted reference, like a pitot traverse, a bolometer, or an inline flow hood. Adjust zero offsets and scaling factors in the BMS. And yeah, make sure to recalibrate periodically, especially in dusty or corrosive environments. Always document your calibration results and keep certificates for future reference. Train your maintenance staff on proper calibration procedures to ensure ongoing accuracy, and set reminders for scheduled recalibrations to maintain system performance over time. Modern airflow measuring stations are, deeply integrated with building management systems. Accurate flow data enables demand-controlled ventilation, dynamic fan speed control, and even fault detection. Make sure your signal wiring is correct, whether it's analog like 4 to 20 mA or digital such as BACnet or Modbus. And always validate that your BMS trends actually match the real site conditions. Regularly review BMS alarms and alerts to quickly identify and resolve any discrepancies or system faults. Schedule periodic maintenance and software updates to ensure your BMS and airflow measuring stations operate at peak performance. And don't forget to train your staff on BMS operation and troubleshooting so they can respond effectively to any issues that arise. Common airflow measuring station problems include things like clogged sensors, incorrect installation signal drift, or even broken cables. Alarms might pop up if there's an airflow drop, which could be caused by filter clogging or maybe a fan belt issue. So, it's important to train your maintenance team to spot unusual trends, inspect probes, and clean them, on a regular schedule. Regular calibration of sensors is also crucial to maintain accuracy and prevent false readings. Always keep detailed maintenance records and refer to manufacturer guidelines for troubleshooting. If persistent issues occur, check for wiring faults or consider replacing faulty components. Here's a real example. There was a retrofit project for a 500-ton chilled water air handling unit which had a design supply of 20,000 cubic feet per minute, but the actual flow was about 25% lower due to duct layout issues. After installing an airflow measuring station, the design team discovered turbulence at the probe location. By adding straightening vanes and moving the probe 5 duct diameters downstream, the measured flow came within plus or minus 5% of design, saving significant fan energy and, honestly, avoiding client complaints. The improved accuracy also made ongoing maintenance easier, since the facility team could now rely on precise airflow data for troubleshooting and optimization. Over time, the building saw measurable reductions in energy costs and improved occupant comfort, demonstrating the real-world value of proper airflow measurement and correction. Thanks for watching this deep dive on airflow measuring stations, from basics to advanced design and troubleshooting. Mastering airflow measurement really does make you a better designer, installer, or facility manager. If you found this helpful, go ahead and subscribe for more HVAC and BMS simplified videos, with real-world examples, practical tips, and step-by-step design guides. Don't forget to like, comment, and share with your network. Stay tuned, and keep designing smart. For more in-depth learning, check out our recommended resources in the video description, including industry guides and upcoming webinars. Hit the notification bell so you never miss an update, and join our community on social media for daily tips and discussions. We value your feedback. Let us know what topics you want to see next, and connect with fellow professionals in the comments or our online forums.